Alright, this is Unit 3 of Polynomials, and we're looking at example 9. And this one's asking us to state if the given binomial is a factor for the polynomial. So there's two ways you can do this. The first way is do your division. So if I divide this, I take n minus 2 and see if it can be divided with this number. So I'm going to take this and divide it by n minus 2. So you do your process. What do I multiply by n to get n to the third? And you get n squared. So n times n squared is n to the third. Negative 2 times n squared is negative 2n squared. Remember, you're subtracting. So the n to the thirds go away. N squared minus negative 2n squared is positive 3n squared. Bring down to 3n. What do you multiply by n to get 3n squared? And it's plus 3n. So n times 3n is 3n squared. And negative 2 times 3n is negative 6n. Remember, you're subtracting. So these go away. 3 minus negative 6 is positive 9n. Bring down the negative 20. Multiplying by 9 would give me 9n, because n times 9 is 9n. And then negative 2 times 9 is negative 18. Subtracting this, that goes away, and I get negative 2. Since my remainder is a number other than 0, this is not a factor. So to know if something is a factor, the remainder should equal 0. If it is a factor. So this is not a factor. So your answer would be no. N minus 2 is not a factor. Another way to test this, if you didn't want to use the long division, but long division will get you the right answer, is if you use your calculator and you find the root of this binomial, and the root is 2, because remember, if you make it set equal to 0, you would add 2 to both sides. And then you just plug in 2 into your expression. So 2 to the third plus 2 squared plus 3 times 2 minus 20. So I just plugged in 2 for the ends. If I get a number other than 0, it is not a factor. When I plug in this value, it should give me 0 to be a factor, which tells you that the remainder deals with the remainders. See how we got that same number there? So plugging in 2 tells me that this is not a factor as well. So again, just a summary, if a number is a factor, or if a binomial is a factor, there should be no remainder when you do division, or if you plug in the root into the expression, you should get out 0. Try the other example on your own.